so I better start now. And wait, it seems like I should be speaking English. And the topic I'm going to share is related to open source software testing. And it's quite an interesting day to give a talk. And I don't know why people ask me. I don't know why it happened on today, but it's more in my. Thank you. And okay, I prefer to go faster, and because quite a lot of things to talk about today, and so I am not very important, and mostly I speak English, Cantonese, whatever. I write code, and I will also show my contact later on. So when it comes to testing, there are quite a number of open source options to choose from. And oh, by the way, how many of you are developers, software developers? Wow, quite a number of them. Any testers? I'm always so fascinated about this because in Hong Kong it seems like nobody does testing. It seems like, but there is also another opportunity where developers do the testing themselves. Take care about your quality. And so for your developers, and then you have already know all these tools already, do you? Can you tell me which one you don't know? All of them? Oh my goodness. And then these are probably the most common ones already, and they are all open source. And in case if you are using any commercial testing tools, please consider that. Like Cucumber, you might have heard of it. This is Robot Framework. Fitness, for those who work on web development. This is Selenium, and this is Water. And so you might not recognize these logos, but you might have tried using some of these, hopefully. And nowadays it's really 2013, and nobody's. No, sometimes, but you shouldn't do many testing when these automated options are available. So when it comes to the choice of testing, my most commonly received question is, which one should I use? And it goes to the question about what you want to test. There are many things that you might want to test about, and it goes down to even to the question what kind of product you are making. But this is what we call a pyramid here that shows how healthy testing is like. I usually compare this like a nutrition pyramid. And whenever I visit companies, then I'll take a look at how well their unit testing is. And so if you want to cover every single line of the code in your system, the most economic way to do that is using unit tests. And depending on how complicated your system is, you might have component testing, integration testing, but at least you should have some system testing as well. This will cover the entire scenario in which you can talk to your product managers. They know the scenarios. And exploratory testing, so I was just talking about we shouldn't do manual testing, but in some cases we still have manual testing. But for exploratory testing, it typically can cover 5% of your system, and it's not repeatable. So try to use these repeatable testing, and exploratory testing actually serve another purpose, which I don't plan to share on it today. And also think about what kind of tests that you have in place. This is a test quadrant that typically categorize what kind of tests you might want to have. Things supporting your team, like unit testing, and then things that give you some more idea about how well your product is, like performance testing. And some of them are more technically related and some of them are business related. So when you are thinking about what kind of testing you want to do, does it cover all these areas? So I typically want to start with unit testing because for developers you should really know about unit testing, and it gives you some idea about how it gives you it. So for testing, so when I talk about testing, people think about how to test a piece of code that it runs, but not only it gives you some idea about whether the logic inside a piece of code is correct, with unit testing, it gives you further insights about how well your code is designed. So I shall start off introducing what is a unit test. And basically, it should focus on a single unit of the code. And it typically has a structure like this. So you do some setup, you execute, and then you compare the result. And this example comes from JUnit, another open source unit testing framework. And in case if you are writing Java, I hope that you know about JUnit and using it already. And I think as far as I know, all major programming language got the unit testing framework as well. And in case if you have a programming language and you don't know what unit test framework is available, you can ask me. I think I can tell you for most of them. And okay, because I don't have much time, I'm not going to go into this. Okay, so JUnit is like this. So from what you can see here, it focuses on a class, or even it's actually focused on a method. How one of the execution part of a method. And when you are writing a test, you can think about, you are essentially thinking about how other people will use your code instead of jumping into how to implement this method directly. And it follows pretty well from the previous talk, learn about your users. When you are writing program, think about your users too. And unit test is a nice example of how you should think about how your colleagues or other users will use the API or the methods that you are providing. And I'm going to skip this as well. Let me see. Okay. And if you are writing unit tests, you probably will encounter this term, which is called test fixture. So test fixture refers to common resources that will be used by a bunch of unit tests. So for example, JUnit, if you put it in a before method, then we will do better resource allocation that can optimize your test better. And the after one, the after method here is to clean up the resources. So that should be quite straightforward. These also help your code removing duplications. And let me see what should go on this stuff. Right. Many of you are already writing any unit tests already. Okay, a few of you. I remember there are more than half of the people out there. So, if you are writing unit tests, for those who are not writing unit tests, you should write starting with now. And if you are already writing unit tests, please think about how fast your unit test is. So, like I mentioned before, it gives you feedback about how well the design is. And each of these unit tests should be running very fast. And when it runs very fast, you will feel comfortable keep running it. Change one single line, run again. Change another line, run again. And that gives you and so you will stay in a green, what we call green, test pass situation. So you feel comfortable your code stay correct. And as you see, time like this is like 0.0 something seconds will finish a bunch of these tests. So yes, if you're writing unit tests already, then please keep it fast. And I want to quickly introduce this. So when we are introducing the concept of unit testing, beginners typically think about how to. It's a way to validate the logic of a piece of code, and writing tests after the code is actually quite a boring thing. That's why I understand why many people don't write tests. So, what are the other ways that we can stay in a well-working code, then that is not so boring? So, some people come up with this idea. Let's write a test even before you write code. This is part of the idea for test-driven development. Write a test, and you don't even have any single line of code, therefore test fails or not even compiled. And then you write code, just enough amount of code that make it pass. And then refactoring refers to how you improve the code without breaking any tests. So as far as the test doesn't break, you know that you are safely improving the code. And then repeat this cycle. I think I still want to do a demo on what I mean by that. So what I mean is, if I am writing a program here, wait, okay, there it is. Have you seen anyone writing program today?
No.
Not yet. Then we should have some coding sessions in the open source software conference, isn't it? And then okay, what I usually like. Can you read it by the way?
Yeah.
Okay, good. What I usually like is to have a test folder and source folder like this. And then I will. Okay, so what I want to start with is something called prime factors. So what is prime factors? I noticed that I don't have a pen here to draw on the board, and I need some way to explain what that is. Okay. So it refers to a very simple algorithm that if the input is 6, then the answer is 2 and 3. So let me see how. If that is 9, then the result is 3 and 3, and so on. So it gives you the prime factor, a list of factors as a result on any given integer. So hope that is a simple enough introduction. And let's go back to the program here. Okay, so like what I said before, I want to start with a test. So in a typical convention, okay, create I need this. Create a test. And so, okay, Eclipse will generate quite many things for me. which I don't need this line for now. And then what is the first sensible test that I should write? Let's start with one. One is an interesting case where one should not have any factors. So one, if I give a 1 to this method, then it should result in an empty list. So should equals. And then the first thing, the convention with JUnit, as far as I remember, the first one is what you put in there, and then the second argument is your expected result. So so the expected result here is an empty list, and I will see it like this. And obviously it's complaining because I'm not importing the list here. And so when you're writing a test, I need to think about some naming and also some basics about this method. And for now, I'm already assuming that it is returning a list. So for writing so far. And the second thing I need to think about is the class here, because Java, everything is object. So it has to have a class. And for simplicity, I will go with a static method here and generate one. And therefore it's still complaining because the class doesn't even exist. And with Eclipse, I can create a class like this. And it's still complaining because the generate method doesn't exist yet. And I can create it similarly. Let's leave it. And then complain again. So don't complain, no more complaining. Everything looks good. By writing this line of tests, I already make some decision about the classes, the method name, what's the input and what is the output. And now I should run the test. It fails as is expected because it's returning a null value. And therefore I should write the least amount of code and make it pass. With this algorithm, with this problem, the least amount of code to make it pass is actually this. It looks quite silly, but it passes. So the second thing so I don't have much code to refactor, and therefore I go on with the next test, and I have already decided to go for a tool which will return 2. Oh, by the way, I can't see the remaining time of it. And I will continue to talk. Don't worry. And the next section is actually a break. Let me see. And it's getting a little tricky here. No, not so tricky, but it's saying integer and then factors. It's a list containing one integer called one integer of 2. Hopefully I can okay, factors 2. Goes here. And it fails because our program doesn't do anything. What would be the easiest way to make it pass? Let's put an if statement here. And if it is divisible by 2, then equals to mu array AC user and it will be empty. And then factors and let's do this. Factors dot add 2. And okay, it sounds good. Yes. And I will go on for the next one. But what do you think the next test is?
Three should be 330.
And then any other choices? Any other options?
6 should be 360.
Yeah, certainly I will go on with 1024. This is an interesting question. So the choice of making the writing tests will actually have some impact to what you will write in how you will implement it. And not surprisingly, if you notice what you see in the left-hand side of your screen, you notice that I have done this exercise quite a number of times. And what I like to do is try form. So what is a special thing about 4 is that the result of 4 is actually 2. And then we have, look at this piece of code, we kind of manage how to deal with 2. And let's make a very small step further. So we will continue dealing with 2's. We have to do. This is naming convention unless someone complains about the grammar. And I will go on with this one. Array list integer. And then factors. And so there should be 2 2's here. And then answer equals prime factors. Here. And again, it doesn't surprise you the test fails. And what should I do? So I do this. Again, I am only managed to do very simple things. Oh, by the way, I do this. And if I do this, and then I'm not very good at writing programming, as you might think. This is lovely. It should pass the test. And well, it isn't really that lovely. Okay, I only got very short time left, so wow, short time. And as most of you are very smart programmers here, so let me show you what should be done instead. And stay very good. Yes, it still passed the test. And for this kind of changing from a statement to a for loop, I can safely change it because I have the tests telling me that okay, it still works. And with only 5 minutes, I should continue it with 3. Otherwise, we will be quite unhappy. And 3 should return 1 3. And let me see. I should actually remove some duplications because it's everywhere. And then itself. And since we know how to deal with a factor of 2, so you shouldn't be surprised by what I'm going to do here, which is factors f3. Wait, thank you. Thank you for warning. Okay, pass again. And okay, so what happens if I do 9? And that should be 2, 3 here. And it's not very surprising, but I understand the time is running out. It will finish quite soon. I should run the test. And again, it is the change here you have seen before. And let me see, will that pass? So it will pass. But as you are developers, you probably won't settle with this solution. And they look incredibly similar to the extent that I should make another problem. The factor, it should start from 2, right? And the factor itself will not be larger than I, and then factor plus plus. And in case if you are curious, I prefer single line for, I prefer no blankets for single line blocks. So factor here, and then factor here. Oh no, sorry, wrong. Here, factor here, and it should still pass. And if you are clever enough, you might notice that it should deal with all the general situation from all kinds of numbers. And in case if you are not sure, you can still add more tests to verify that. But even for a problem like this, the solution turned out to be that simple. I'm not sure if have you thought about how you will solve this problem, but with tests protecting you all the time, you will have the confidence to improve the code and keep it in a good shape. So all my time is used up. Is it? Okay. Any question?
I'm newcomer to the test-driven development, and I really like it because it really helped us during the development. Especially, it helped me to look to find out what is the affected area of any change. But I wondered in many cases, I am really frustrated. For example, recently I'm developing a game like CCP. I have tried many cases to test my simulation algorithm. However, suddenly I found that the original algorithm is too CPU intensive, is empty hard. And then I found a 3D algorithm that is doing well. Then I am very frustrated because all of my test case is lost because the algorithm is no longer valid. Any comment on this? Because it appeared not the first time and already many times for me.
So it is a design problem.
Yeah.
Whether so go back to is a unit? The problem is what is a proper unit? And within these units, they should talk through interfaces. And if you write unit tests like that, then you are taking a user's perspective to look at how to use the other piece of the code. So with a well-designed code, in the text, what you can see from the text is that it won't care whether it's a greedy algorithm or you're using brute force algorithm. And also like this prime factor example, of course you can go measure the complexity of this method. And if you just look at the unit test, it has no knowledge about the algorithm behind. So if you want stable testers, my recommendation is test through the interface. And then for the let me see. The primary recommendation is to test through the interface. The test should not know about the implementation. And then you might still have other level of tests too. But if your text knowing too much about the details, then whenever changes happen, you will need to change the objects. And which is quite unfortunate because I actually have more to talk and I noticed that I only got 30 minutes. And if you are writing tests and if your test script focus on what we call the technical level, knowing the technical details and so on, what will happen is when there are some changes in the requirement, then all bunch of tests will need to change. And it's therefore not very stable, and there are not technical details to read. Therefore, the clarity of the test is hard to maintain. It is usually this period usually refers to the functional testing. When we talk about functional testing, like if you have some experience writing Selenium scripts, you will know that what it does is essentially controlling your web browser. You need to tell the web browser that the URL is like this, and then wait for half a second, tell them the doom ID, and then in the text box type username, another doom ID, type the password, and then tell the doom ID of the submit button. Okay, press it, and then wait for another 30 seconds only to do a login. And if the UI changes, then this will change again. But if you're writing tests, try not to expose too much details. So that's it. This general guidance applies to both unit tests and functional testing. And if your test is focused on the business rule of what it is doing, and that will give you the clarity and the stability. Therefore, it's hopefully more maintainable. I'm not very sure if I could answer your question. Okay, good. Yeah, because I might want to know further details on what happened. Yeah, the last.
How many test cases enough for how is it? The code side of test case function other than the source code?
It really depends. So the primary thing that depends on is the complexity of your program. And it goes back to the design question. How much complicated you want with a unit. And if it's getting too complicated or the complexity is getting too high, the question I would ask is that whether this class or this method is doing too much. And if it is doing too much, isolate it. And of course, the complexity doesn't go away.
Loss of state. Yeah. You have to compare it also, for example, if there's technology, state, like something have to change all this stuff.
What is that again?
I mean,
if it is a unit test, if you're asking, you have a piece of code and you want to unit test it, the very quick answer is that prepare what the before state is. Execute, do one step, and then verify the next state. So this is if you're looking at unit level, it's essentially those like this. So it's only step by step. Instead of doing a series of things that will get you to that particular state, and then do the test. So I try to isolate these steps because if you're not isolating, there will be many combinations of things that you need to cover, and it's a maintainability help. I understand your puzzle. So
yeah. I know. It depends. Yeah, thanks.
So that's a general guideline, and it will be much better if I can look at the code. And so I don't want to occupy too much time, too much of your time.
Okay.
Please continue. Great.
Okay. You have a very short for around 5 minutes, and then okay. Actually, this session is end, and then after 5 minutes, we will have a keynote from web page at room 4001. Yeah.
Actually, it's better to go out there and go inside like that because there's more seats in the front. The seat at the back already occupied. So it's easier to go